And welcome to another problem in USACO Silver Prefix Sums of Unit 1. Today we're going to be covering a bit of a difficult problem from February of 2021, so fairly recent problem of USACO Silver, just green enough. So our problem is very simple to understand actually. We're given a grid of numbers, and I'm just going to take the sample case 57, 120, 87, 200, 100, 150, 141, and 135. All we're looking for are subgrids that contain, or subgrids whose minimum is exactly 100. Let me show you an example. This is a subgrid because this is a subgrid that satisfies our condition because the minimum is exactly 100. But let me show you a subgrid that is not. If we take this subgrid, the minimum would be 87. So this isn't a so this does not work. So how we can solve this problem is instead of the problem asks us for exactly 100. This is a key word. But it's actually easier to calculate the number of subgrids that are greater than or equal to 100 minus the number of subgrids greater than or equal to 101. This is kind of like complementary counting if any of you have done combinatorics before. And we can kind of use this idea to solve this problem very easily, but it's still hard. Now, let's see how we can calculate the number of subgrids over 100. And note that this is the same method to calculate the number of subgrids over 101 as well. So it might be useful to define a function for this. Define a function. So let's take a look. All I'm going to do, this was the original grid. I'm going to convert this into a new grid that I have over here. And I'm going to use zeros and ones. Notice where I'm going to mark zeros and ones. If the number is less than 100, it becomes a 0. But if the number is greater than or equal to 100, this becomes a 1. So all I've done is I've checked every single number, and I'm checking, okay, is this number greater than or equal to 100? If so, mark it as 1. So I've transformed this into this type of array. But so now what we've done is we turn this problem into counting the number of subgrids with just ones. So for example, this would work, but take a look at this one. This one wouldn't work because look, there are 2 zeros in here. These zeros means that the subarray or the subgrid is less than 100. The minimum is less than 100, so it doesn't work. So we just need to calculate this case. But how can we do that? But before we start to solve this 2D matrix hard problem, let's try to consider like a 1D case, so like a number line. So if I have this and I ask you, okay, how many subgrids can I make with just ones? Let's take a look. That's 1, 2, 3, 4, 5, 6, 7. These 3 ones. So there are a total of 7 ones. How did I do that though? Let's take a look. Let's just consider this 111. So all of these. How many subgrids can I make with 111? Take a look. I'm going to consider different sizes. If I have size 1, how many size 1s can I have? That's right, 3 of them. 1, 2, 3. What about size 2? For size 2s, it's 1 and then 2 like that. So there can be 2 size 2s. And then let's take a look at size 3. For size 3, I have to include every single one. So it's going to be 1. Notice the pattern here. I'm decreasing the number by 1. Minus 1, minus 1. So number of size 1s is n, and then I get n minus 1. So let's say that this length was equal to n. And then I'm going to get n minus 2 all the way until 1. So I've broken up this very simple case into different cases of sizes. So now all I have to do is I have to add this up. And we have a formula for that, and that is this. Calculating sum from 1 all the way till n. If you've done a little bit of competition math, you should know this formula. So it's just n times n plus 1 over 2. So let's see how we can write this into a function. All I've done here is I'm defining a function. So this function, all it's going to do is calculate number of 1D subgrids. So let's see. I'm taking a vector as an input. So for example, if I'm trying to calculate this one, the one that I have right over here, my vector is going to look something like 1, 0, 1, 1, 1, like that. The number of consecutive ones is going to be 0. My answer, which is what I'm going to return at the end, is also 0. And for each element inside of my array, what I'm going to do is, if it is 1, that means that I have another consecutive 1. So I increase it, increase consecutive. But if it is 0, look, there's a 0 here. That means that my series of consecutive numbers has ended. Oh no, it's done. So now what I'm going to do is remember the formula that we talked about up there. I'm just going to apply it directly here. And I'm just going to add that on to my answer. And then, since it's a 0, that means that our streak, or our consecutive ones, is over. So I'm just going to set this equal to 0. And at the very end, just in case there are no more zeros here, I'm just going to add this one more time, and then I'm just going to return the answer. You can take a screenshot of this code and use it in your very own solution. So now we know how to solve a 1D case of zeros and ones, but how can we solve a 2D case? Let's consider this. Consider bounds on a subgrid. I have drawn in very thick lines over here, these bounds. And what I'm trying to find is a subgrid of column length, or width of length 2. So for example, this one would work, but take a look at this one. Would this work? No, because the width length isn't equal to 2. It must touch the mounds basically. So let's take a look at this one. This one would work, this one would work, and these 4 would work. But let's take a look at this one. Everything in here. This wouldn't work because there's a 0 in there. How can I use the rows in this? But let's take a look. If I have 0 and 1 here, can I include this row inside of my subgrid? No, because look, there's a 0 here. That means that our condition is being violated. So we know that we cannot use this row at all. So I'm just going to make this into a 0. Let's take a look at 1 and 1. Since everything here fits our condition, I'm going to turn that into a 1. Let's take a look at 0 and 1. Oh no, there's a 0 here, so this wouldn't work at all. So I convert it back into a 0. So notice I turned this 2D into 1D. Okay, let's take a look at this one. So can this row be used in my subgrid? No, because ultimately what we're trying to do is we're trying to configure the rows together. So for example, okay, I'm going to choose these 2 rows or these 3 rows, and to see, can I use those rows? So this one is a no, this one is a yes, and that one is a yes. All I'm doing is I'm checking. If there's a single 0 in there, I cannot use that row. So I convert it all into zeros and ones. And now look, I've turned, once again, a 2D problem into a 1D problem. So now what I'm going to do is I'm going to use this and put it into the function that I defined right up here. And the answer to this function is going to be the answer of how many numbers or how many subgrids can be in this bound that I have defined. So our main idea is for every possible pair of column bounds of size 1 through n, so if I have something like that, let's say, and let me draw it again. So if I have a 3 by 3 like that, all I'm doing is I'm checking, okay, what about this one? What about this one? What about this one? So that was size 1 column, but as I've showed you above there, size 2 is going to be this and that, and size 3 is going to be everything in there. And all I'm doing is I'm finding how many subgrids there are using just my function. But prefix sum is involved in this as well. When I'm calculating these side numbers right over here, so I'm taking these two and comparing them, I have to go through each and every one of the row numbers, which is a bad idea, which adds on to our time complexity. So what I'm going to do is I'm going to use a prefix sum to determine if the number of ones matches. Let's take a look. So I have my thing over here. So same thing. And then I'm going to calculate the prefix sum of the number of ones. Okay, so for the first row, I'm going to get 0, 1, 1. Second row is going to be 1, 2, 3. And the third row is going to be 0, 1, 2. And let's say that I wanted to calculate, okay, I want to see if these two, if it's just ones or if there's a single 0 in there. How can I do that? Well, I can take this number and subtract it from this number. Remember prefix sums. If you don't, go back to USACO guide and see how you can calculate prefix sums. All I'm doing is I'm calculating prefix sums of single rows here, like that. Okay, and I get 3 minus 1, which is 2. And how many numbers are supposed to be in here? 2. So since these two numbers matches, I know that this row is valid. So I can convert this row into a 1. But let's take a look at these two numbers, 1 and 0. We obviously know that this should be a 0. But how can we use prefix sums to verify this? I have a 1 here, and then I have a 0 here. So I subtract these two numbers, and I get 1. So I know that there are 1 1s in there, which is bad, because I'm supposed to have 2 1s, but I have only 1. So since these two numbers don't match, I set it equal to 0. So our main idea was to reiterate for every possible pair of column bounds, I'm going to find out how many subgrids there are using the function, and then I'm going to add the sum onto the total count. So let's say that I define this as a function. So what I've talked about from here, so from this slide all the way to the end slide over here, that's going to be a single function. And what my answer is going to be, or the answer to the problem is going to be my function of 100. So the minimum is supposed to be a 100, so 100 and over, minus function of 101. So that's going to be our answer. Hope you enjoyed this video and see you in the next one.